That's good. Oh, hello guys. We've lost the iPad. How are you today? Could you make sure you comment your names so I know who's in the group? Let's try and get this iPad working. Hurry up. There we go. Cool. All right. So yeah, today we are looking at. Oops, maybe don't minimize it there. Today we're looking at hypothesis testing, which is coming up to the end of the stats part of the course. Cool. Right, that's working. And so we got Harry, Lucas, Emily, and Finn. Cool. I might go slow to start with. You might have noticed as well I have hiccups this morning, which is great for streaming. Yeah, so we're just gonna quickly recap how to do binomial hypothesis testing, and then we're going to talk about the other two types, which is all we've got left of the course now, is normal hypothesis testing and testing the correlation of a sample. Hi Ella. Hi Ben. I guess I should do the register. Let's do the register now. Cool. So we've got cool, right. So Harry and Lucas and Emily, it's all old school now doing all these registers. Harry, Lucas, Emily, have we got Tom yet? Nope. Amy, Isla, Ben. Sally's watching but won't let her comment. Okay, thanks Sally. Cool, got you there. Anybody else watching but not able to comment? And Finn there as well. Cool. Alright, that's it for now. Good. So yeah, please do excuse my hiccups. Hopefully they'll disappear at some point during the video. Alright, so binomial hypothesis testing. So this is the one we did last year, and we did a bit of revision on about a week ago. So hypothesis testing when you're using binomial is to check if the probability is accurate. So in other words, saying given my sample, I've worked out probability. Does that fit with the probability of the overall population, or is the overall population probability probably false, possibly a lie, or a dodgy claim? Hi Eliza, I'll just swipe you in as well. Cool. So yeah, let's write that down. So tests if probability is accurate. So if they told you the chances of winning a prize was 0.7, and then we'd be testing, well, is the chance of winning a prize 0.7? I've taken this sample, I won this many times. Does that fit with this probability? Does that make sense? Is there a chance that this could happen given that this probability is meant to be true? And if the chances are really slim, we say, well, probably the probability overall for the whole population isn't 0.7. Maybe that's a lie. So in all of these cases, we are taking a sample, doing tests on it to see how statistically likely the things we find in the test are the same as the overall population. So that's the whole idea behind hypothesis testing. Small sample, do some stats on it, see if your results match up. iPad's being a bit weird today. Let's hope it's all okay. So yeah, it's doing some tests on a small sample and seeing if the results agree with the stated results for the whole population. Okay, so what we're going to be looking at today and this week is the normal distribution testing. So with a normal distribution test, we're not testing probability because obviously probability is one of your what's the word I'm looking for here? One of your parameters of a binomial distribution. The parameter we're going to be testing with normal distribution is our means. So what's going on? This isn't good. I might just try. If this happens again, I'll get a different lead, and we'll see if it's a lead problem. Okay, normal distribution then. So we're testing if the mean of a sample represents the mean of a population. So if a company made a claim such as phone battery lasts an average of 12 hours, I could get a load of phones, I could test the mean and see if my mean makes any sense in the overall population. See what the probability is of having the mean I've got compared to the stated mean of 12 hours. Is the mean I've got statistically unlikely if they've claimed the mean should be 12 hours? So all the way through, it's samples and populations. And correlation is our last thing we're going to do in stats. It tests if the correlation coefficient. So remember, R was the value between -1 and 1, which is the product moment correlation coefficient, the PMCC. Represents. No. Test if the PMCC, the correlation coefficient for a sample, represents the PMCC for the population. So in other words, if we got two variables trying to test if they're correlated, we could test a sample, see if the sample's correlated, and decide whether that suggests the population is correlated as well. So all of these things, take a sample, test it to infer stuff about the overall population. Cool. All right. So we're going to try a hypothesis test. I think the only way to do these really is kind of jump into it. So I've found the data for the best iPhone. So apparently the iPhone, what's it called? The 11 Pro is the best iPhone currently, and Apple on their website state the video playback if you're streaming is up to 11 hours. So they've stated that the mean battery life should be 11 hours. So my population, if we do this up here, the claim is the battery life B is a normal distribution with a mean of 11. And I had to guess a standard deviation. I thought maybe 1.5 hours would be fair to give Apple a chance. 1.5 spread on those values. Yeah, cool. And remember, with a normal distribution, we're talking about x and mu sigma squared there. Cool. Yeah, 1.5, should we use that? Yeah, cool. Okay, go back to correlation. Yeah, sorry, Lucas. Have a quick read there. So just testing if the PMCC that you've got in your sample represents the PMCC in the whole population. Okay, so now that I'm a big YouTuber, if I bought 10 iPhone 11 Pros, so I buy 10 iPhone 11 Pros, because I can afford that now. I've got all my YouTube content coming in. And let's say that Exam Solutions, my main competitor in this world, ex- Exam Solutions buys 10. And some other people, I mean, Dr. Frost Maths, he's pretty good, buys 10. And Physics and Maths Tutor, he buys 10 as well. And Number File, they buy 10. So we're all buying 10 of these crazy expensive iPhones. And let's say we all calculate the mean of our sample of 10. And we all come up with different means. But all of our different means should fit a normal distribution. So if you've got a sample, if you take lots and lots and lots of different samples of a population, the means of all of those little samples should fit a normal distribution as well. So the normal distributions, the means are also normally distributed. So the sample means of a population are normally distributed. So let's just move me out of the way. So yeah, if you've got a population, take a sample, take lots and lots of samples, work out the mean of each sample individually. All of those means should also fit to a normal distribution. They should all be close to the mean, getting less likely as you work your way out. Cool. So we can write down the sample mean distribution. So we can say B with a bar on top of it, sample because it's a mean. So we got B variable, but it's the mean of the battery life, is a normal distribution. Now the mean should be the same. If the mean of the iPhone thing was what they say 11, the mean of our samples should also be 11, and the mean's not going to change. So we get mu here. Now the standard deviation does change because obviously we don't have as much data, so the spread is less likely to be sigma. The spread gets reduced depending on how many data points you've got. So the mean distribution should have a sigma of sigma squared over n. So sigma is still squared, but we're now dividing our spread by how many data points are in our sample. So if my sample was 10, we're going to divide sigma by 10 to make it fit. Because it's unfair for it to have the same spread when there's only 10 points of data. There's not the whole population anymore. Why do we not have as much data? Because we've taken a sample. The whole population is all the iPhones in the world. We've sampled 10 of them. So, if you plotted a graph of 10 data points, it's not gonna spread out as much as a normal distribution. Okay, so try and remember that. So the normally distributed means of a sample should also be normally distributed from a population. And that's the key bit there. The difference is you're dividing your standard deviation, or you're dividing your variance because sigma squared is the variance, dividing your variance by n. Okay. All right, so let's write that out again just so I've got it here. So we had the mean of the iPhones Battery life. So the original sample B was 11, 1.5 squared. Did I square it in the other one? Yeah, sorry, that should be squared there, guys. And our mean sample, mean distribution, should be 11, 1.5 squared over 10, because 10 was our value of n. 10 was our number of data points in the sample. Okay, so let's say I buy 10 and I get 10 hours as my mean. So I'm saying, well, the box says it's 11 hours. My mean's 10 hours. I doubt their statement. So my null hypothesis is that the mean is 11. Yeah, null hypothesis, nothing has changed. Same as it was in binomial hypothesis testing. The null hypothesis is that the mean is as they've stated. The alternate hypothesis, well, I think it's less because I got 10 hours, so I'm gonna test is the mean less than 11. So we're looking at one-tailed test. And let's test it at the 5% level. So test 5% level. Cool. We're going to see, can I complain? That's if it comes out, yeah, this is statistically unlikely. I'm going to complain to Apple and hopefully get some free iPhones. All right, so let's plot our sample mean distribution. So we're going to plot this one. So the mean is 11. 10 is the value I've got, so let's put 10 as here. And we are now trying to find out what is the probability. And because I'm testing at 5%, if this probability comes out at less than 5%, so it's less likely than 5%, what that says to me is that given a mean of 11, how likely is it to get 10? And if it's less than 5% likely, that's quite unlikely. It means that the mean probably isn't 11 with the iPhone. So we need to find out what that area is. So we're going to bring up our ClassWiz calculators or graphical calculators, whichever. And go to normal distribution. Now we want to try and find the probability. So it's a standard NCD question. Lower is going to be 0. Upper is going to be 10. Now sigma we need to be careful with. Sigma isn't 1.5, nor is sigma 1.5 over 10. Sigma is 1.5 over the square root of 10. Reason being, if you see that our standard deviation was 1.5, so the variance is 1.5 squared over 10. To get this to turn into standard deviation, we need to square root both bits. Root 1.5 squared is 1.5, which is why we've got 1.5 here. And to the bottom, we need to root the 10. It's really easy to forget to do that. I did when I was planning this lecture yesterday, so don't forget to root the 10. Root 10 for sigma. So you get 1.5 over root 10 as my sigma. And what was my mean? Well, the mean is 11, same as it was in the population. And we can draw it just so we get a nice idea where this is. So if you look at it, 10 is right down the bottom of this. My probability is 0.0175. Cool. So according to this, because 0.175 is less than 0.05. Evidence to reject H0, and then I have grounds, or I have reason to complain. Battery life. Running out of room here. Battery life is not 11, is what I want to say down there. Battery life is not 11. Cool. Hopefully that made sense to all of you. That was the kind of basic version where we're just testing the probability. Normally when we do this, we'll find critical regions like we did with the binomial, just binomial hypothesis testing as well. Cool. I'll just give you guys a sec to copy that down and think if there's any questions that you want to ask. Anybody else logged in? Because we are still missing a few people on the attendance. I think Ollie's coming on Thursday, so... Oh no, Ollie came yesterday. No, that was a different lecture. I think Ollie's coming on Thursday. Is Tom here, or is Ruben here? We're missing you guys still? Don't know. Cool. If you guys do come in, either send me a message or an email. All right. Cool. I guess there's no questions then. Good. All right. So we're going to try this question. So, can you guys see that now? Ollie went for a surf. Cool. Yeah, I thought he did. Okay. I can barely see this question. Machine then. It is amazing weather. Okay, so a machine produces bolts of diameter d, where d has a normal distribution with a mean 0.580. So let's write down what we know straight away. D is normal with a mean of 0.580 and standard deviation of 0.015. Cool, so I've written down my population distribution, let's call that. Okay, the machine is serviced, and after the service, a sample of 50 bolts is taken to see if the mean diameter has changed. Okay. The distribution of diameters of bolts after service is still normal with a standard deviation of 0.015. So, got population. We've got a mean that we need. If our mean bolt diameter has changed, maybe our bolts are going to be useless and we're selling the wrong things. So we need to do a sample to see if the bolts still work after we've serviced this machine. So it's told us that the mean of the sample, or the sample means, that's what we're trying to test. And the standard deviation is still the same. So I can say my distribution, the mean distribution, is n. We're assuming it's still 0.580. That's what we're going to test. And our standard deviation, 0.015, standard deviation squared even, divided by n, and n was 50. So that's my sample mean distribution. Okay, so we're trying to find a critical region. Critical regions are a little bit more involved. So to find a critical region, we need to find z values. Oh. We probably could do on a calculator, but let's go through finding the z values first anyway. So if you guys remember, the z equation was z equals x minus mu over sigma. Because we're using a mean distribution though, it's not going to be sigma, it's going to be sigma over n. So we need to remember to divide this. Cool. And what we're basically looking for, if we're doing a hypothesis test at the 1% level, it means we're going to have 0.05 for each tail, so 0.5% for each tail. So 1% level, that area there is 0.05, that area there, 0.05. and the mean 0.580. So we're trying to find the critical region. We're trying to find these two values based on these two probabilities, based on a sampled mean distribution. So let's work out Z, and when we've got Z, we're going to put Z into that blue equation over there and use it to work out what X is, which is our critical regions. And I think in part B, we're actually going to do the test. Cool. So if we bring up the calculator, this time we know the probability, so it's an inverse normal. Yeah, thank you guys for watching. I know it is beautiful outside, but we've got working from home to be doing. All right, so inverse normal. Tail, we'll do the left-hand tail first because that's what you can do easily on the class with. To be honest, Z's going to be symmetrical anyway, so it doesn't matter too much. Area then, 0.05. Wait a minute. Test at the 1% level. 1% is 0.01, so actually I want this to be 0.05, so I've made a mistake, but I have spotted it, so that's good. Let's just fix that up. Cool, all right. So put 0.05 in, put sigma in. Sigma is going to be 0.015 divided by square root of 50. Remember, we got to square root it. And my mean is 0.580, supposedly. Cool. Right. So what values would be unlikely to get if the mean is 0.580? So trying to find the values that would be, yeah, probably suggesting the mean isn't that. So I get my Z value equals plus or minus 0.5745. Yeah, let's go to 4. Cool. Right, don't need the calculator anymore. Back to me. Oh, Tom. Hey, Tom. I'll take you off now. So, yeah. We've got our Z value. We're now going to try and code this Z value to find out what these are in terms of the actual question. So what the values are in terms of a bolt diameter. And we're looking for something in the region of 0.580. So, if we work these out separately, 0.5745 equals x, take 0.580 divided by sigma. What was sigma again? 0.015 over 50. Cool. And z is plus or minus. There's two of these. I'm going to kind of skip this step because I'm sure you guys can solve that equation. So we get x equals, or d, I guess, because we're talking about diameter of the bolts. So my lower value is going to be, can I see it on the screen? 0.575. My upper value, d, is going to be greater than or equal to 0.585. So that's my critical region. If I find a bolt that's outside of those two regions, we need to have a think about what's going on. So part B, the mean diameter is calculated to be 587. Ooh, that's outside. So their value that they've got, 587, is outside the critical region. Or sorry, inside the critical region. It's outside the acceptance region. So I'm just going to make a bit of space here. Isn't it root 50? Yes, sorry, it should be, shouldn't it? Yes, that should be root 50. It was in my notes and I ignored it. Sorry, let's recalculate this. So if I go back to the calculator, who spotted that? Good job, Lucas. Right, sigma then should be What was it? 0.015 divided by square root of 50. So we actually get, this is interesting. 5, 7, it changes nothing. It doesn't matter. Good, cool. Save the day. Answer's still the same. Yeah, that 50 and root 50 didn't affect anything at all. Oops, skipped. Oops, skipped again. Yeah, cool. So yeah, sometimes it doesn't actually have that big effect. So yeah, didn't matter in this case. So those are my two values. If we look at what they've given us, so they've said the mean is 0.587. So 0.587 is inside my critical region. So that would be somewhere in here. Let's just make some space. So 0.587 is inside critical region. So likely the mean has changed. Cool, so we're going to accept H1. I forgot to write my hypotheses down for this one. So just to make sure we got those, H0 mean is 0.580. Oh, my hiccups have gone. That's good. And H1, oops, H1 dot dot should be dots, not equals. Mu is not equal to 0.580. Sorry guys, I did forget to do this. So those are our hypotheses for this test. Oops, God, I keep changing this today. Cool. All right. Has anybody got any questions about this one? I'll give you a couple seconds to ask if you do. So no, the hypothesis test is always quite a lot to take in. So got a population, stated a mean. We're testing if that mean is true. Taking a sample, looking at what values would be unlikely to get for the mean of the sample. If we get a mean that's in that critical region, then it's likely the hypothesis, likely that the stated mean of the population is wrong. All right, so we're going to move on. And I think I'm going to get you guys to try one. So, not harder, but it's a little bit wordy. So maybe I'll read it through and talk you through the basics, and then you guys can give it a go. Okay, so the mass of European water voles, M, is normally distributed with standard deviation 12 grams. Given 2.5% of water voles have a mass greater than 160 grams, part A, find the mean mass of a water vole. So part A is basically find the mean, so it's nothing to do with hypothesis testing yet. 8 voles are taken at random, find the probability got a mass greater than 160 grams. Well, that's a binomial question, so you need to do a bit of binomial distribution in here as well. And then we've got a hypothesis test at the end. So I'll label the parts for you guys and you can try it all. So part A is a normal find mu. Part B is a binomial. And part C is a normal hypothesis test. So overall, it says it's worth 10 marks. I'm gonna give you guys, I think, a bit longer than that. I might give you guys 11, maybe even 12 minutes. I want you to thoroughly give this a try. So I'll just write down the key equations you need. So z equals x minus mu over sigma. Also, if you want to use a table, you could, if you got it written down anywhere, because it's 2.5% and it's greater than, you could use the hypothesis tables. It's not that. You could use the percentage tables if you wanted to, rather than use a calculator. Yeah, give it a go though. So we'll put 12 minutes on the timer and we'll see how you guys get on with this. Please comment if you get stuck because there's quite a lot going on in this question. But yeah, part A and part B is revision of what we've done before. Part C is what we're actually looking at today. Yeah, I won't go through it too fast. I'm just trying to work out. It seems the screen isn't fitting today. Trying to make it so you guys can actually see everything that's going on. Um, there we go. Okay, weird. Yeah, I'm not sure what's going on. You got Z equals x minus mu over sigma anyway. I'm just going to try and fiddle with my settings, see if I can. Can't do anything while I'm streaming. Okay, we'll have to deal with it for today then. Hey guys, sorry, I just went to get some breakfast. um, I was trying to fix the screen because it wasn't showing everything properly. So yeah, it just about fits, but I've lost a lot of my usable iPad screen. It looks fine now though. Yeah, the last day one lecture was on histograms. That's true. Um, yeah, cool. So anyone need any help with this question so far? Remember to type your answers when you got them. How do you find the mean? Um, Sketch a normal distribution. Shade in the area that 2.5% is greater than 160. Find Z, and then put X, Z, and sigma in, and you can find the mean. So it's the stuff we were doing on Friday, I think, finding mu and sigma. I think it was Friday's lecture. X is M, or X would be 160 grams. Z is the value from the table, Harry. You should know that. That's a bit interesting. Z is your standard normal distribution X value. So D would be your normal distribution. Z would be your standardized. Remember the one with the mean of 0 and sigma is 1? Oh, sorry. Z should be 1.96, I believe, for this one, which should lead to a mean. Well, you can do that bit. But yeah, Z should be 1.96. Lucas, don't worry, is hard at first. Which bit you stuck on, part A, B, or C? If it's part A, sketch it. Draw 160 at the top somewhere, because the probability is more than 160 is slight. Put in the probability 0.025. Go into your table or go into your calculator to find Z. Remember, Z has a mean of 0 and standard deviation of 1. And you're uncoding Z to get back to find mu. Mu should be 136.48. Let's go through it then. Weird. Now it's moved the whole screen back up. I don't understand what's going on my stream today. Um, Cool. Hey guys, thank you. Yeah, I don't know what's going on with resolution today. I think it's squashed everything. Anyway, let's give this a go. So part A, we're looking at a kind of standard normal distribution. So if we sketch part A, we were told standard deviation, so mass of the water moles, normal, don't know mean, and we know sigma is 12. We know that 2.5% of a mass greater than 160, so if I label this as 160, this probability here is 0.025. So we can find Z, because remember Z is a normal distribution with a mean of 0 and a standard deviation of 1. So I can bring up the calculator. And with the calculator, we'll put in our probability. So we're using inverse normal again. My tail is to the right this time. So if you are using the class Wiz, you'll need to do 1 minus the probability. Area 0.025. And sigma was 1. The mean was 0. Because we're using our standard distribution. And you need to use a standard distribution whenever you're trying to find mu or sigma. So hit execute. And I get Z is 1.9, let's call it 1.96. Cool, okay. So with my Z value, we're then going to code this to try and find out what our mean is. So using Z equals X minus mu over sigma, so 1.96 equals X, which was 160. Minus mu, or mu is 0. Sorry, what am I talking about? That was the other distribution. 160 minus mu, the thing we're trying to find, divided by standard deviation, which was 12. And if we solve that for mu, we find the mean. So if you're solving that, you should get mu is 136.48. Cool. Anyone got any questions on that bit? So it's a standardized normal distribution. We're using it to find an unknown mean. Okay, part B then is a binomial question. The reason I know it's binomial is because it says 8 water voles are chosen at random, find the probability at least 4. So when you're dealing with numbers of things, it's a binomial question. So if I make some space, we need that probability, so I'm going to write that down at the top. So mu, let's just write it down as m, normal distribution, 136.48 and 12 squared. So there's my distribution. Now I can get rid of the stuff in red. Cool. Okay, so 8 voles are chosen at random. Find the probability. So let's do this as a binomial, and we want the mass is greater than that. So yeah. So n is our number of voles. N is binomially distributed with a number of trials as 8 and a probability of success. We don't actually know the probability of success because we want to find the probability that they have a mass greater than 150. So we need to do a bit normal first to find that probability so we can put it into our bit here in black. Okay, so before we finish off this binomial bit, we're going to go back to the normal again. And we want to find the probability, so normal, the probability, oh my god, what have I done? Probability, Probability of a mass greater than 150. So this is our normal distribution, and once we've got this probability, this is going to be the probability we write in here for our binomial distribution. So if I bring back the calculator, we're going to put in standard distribution, so we're not using our inverse this time. So the lower value is 150. The upper value, let's just put in a big number. Sigma is 12, and the mean is 136.48, like we found just now. So draw it. There we go. So our probability is 0.1299. And that's the probability we're going to use for our binomial. So if I write that in here, 0.1299. And for our binomial question, we want the probability that at least 4. So we want n to be greater than or equal to 4. So we can do this on a calculator as well. So we're going to go back to distribution, binomial this time. We're trying to find a probability, so BCD. Lower is going to be 4. Upper, well, there's 8 water vols in total, so upper is going to be 8. Number of trials is 8, and probability of success is 0.1799. So 0.1299. Can't read my writing there. Cool. And calculate. And we got a probability for our water vols. It's going to be 0.01. Cool. Right, anyone got any questions? I did that kind of fast. So it was a binomial question. We didn't know the probability, so we used a normal distribution to find the probability so that we could do the binomial question. Cool. Okay. So the last part is our hypothesis test, which is the hardest bit. Did anyone do the hypothesis test yet? Because I would like you guys to try it. If you didn't get round to it because you were stuck on part A and part B, that's fine. But I might, unless anyone's kind of succeeded with it, I might give you guys a couple minutes now just to give this one a go. Cool. All right. 4 minutes. So state your hypotheses, state the mean distribution, and then trying to test what the critical regions are, and see if our 875 is in the critical region. Right, give it a go. 4 minutes, and then we'll go through it. Finn, yeah, it looks alright on my end for what's broadcasting. Check your screen settings like Ben suggested. I can't do anything here on it because it does look pretty clear on. I'll just see if I can log in as a separate YouTube, see if anything's going on. Yeah, I think it's just you. It looks fine on my YouTube here as well. Cool. All right. So let's go through this and give it a go. Oh, weird. Now all of my screens showing up again. What's going on with the stream today? Weird. Okay. So, yeah, hypothesis testing. Let's get rid of all this stuff. Don't need it anymore. And I think I'm going to move things up. Okay, so we've got different type of species now. Hopefully you guys spot it. We're looking at European water rats instead of European waterfowls. Good. So these guys are distributed with standard deviation 85. They haven't told us the mean there, so let's keep reading. Blah blah blah. Okay, mean mass 875. Okay, so it's whether it's different from 180. So we're going to assume that all the water rats have a mean of 180 or 860, and the standard deviation is 85. So that's my population. My sample means is going to have the same mean, and its variance is going to be 85 squared over 15 because that's our sample size. And state our hypotheses. So H0 P equals, sorry, one more time, I got stuck in binomial there. H0 P mu equals 860, and H1 mu is it two-tailed or one-tailed? Different, so we're doing two-tailed, not equal to 860. Mu is the mean mass of water rats. Oh. Cool, I need a different lead. God, everything, technical difficulties today, terrible. Sorry. Okay. So, we've got our hypotheses and we've got our distribution. Okay. So we're using a 10% significance level. So if I sketch that, maybe up here, there's my distribution. We're looking for 5% either side. And we're going to do that again by finding which values those correspond to. So if we bring up the calculator, we're going to type in 0.05, put in our mu as 860, find the two values either side, and then see if our test statistic, which was 875, is in the critical region. Cool. Okay, so bringing up the calculator. And we're still in binomial, so let's go back to normal. We know the probability, so it's an inverse normal. Let's do tail to the right. Yeah, we can do that. All tails to the left. 0.05. Sigma was 85 over root 15. And mu is 860. Cool. So my upper value is going to be 896. My lower value, if we do the lower tail, is going to be, say, everything else is the same there. So let's execute that one. 823.9. Okay, and we're trying to test if 875 is significant. So 875, if we look at it, it's, well, 875 will be about here, which isn't in the critical region. So 875 is not critical. So let's write it out properly. So critical regions are n is less than 823.9, or n is greater than 896. 875 is not critical, therefore mean is not different. Which hypothesis are we accepting? The null hypothesis. Accept H0. Good. Right, has anyone got any questions before we move on? Cool. Right, moving on then. I'm going to skip the next question because it's massive, and with my screen not working very well, I don't think it will leave much room for workings. So, yeah, let's try the next one, which is a bit smaller. Cool. Right, 4 marks. Going to give you guys 5 minutes. Standard question this time. Just a hypothesis test. There's nothing else going on. See how you get on. I really want you guys to try this and see if you can comment your answers as well. So give it a go. Say 4 minutes on the clock. Message if you get stuck. Sorry guys, just realised that some of the screen was clipped out there. That is the whole question on the board now. So 2 minutes. Let me know if you need any help. Please post in the comments. I did it. I have to go though because my lesson's starting again. I'll see you in a bit. All right, guys. Cool. Let's do it. So, daily mean wind speeds models being normally distributed with a standard deviation of 3.1. So, let's use W for this. Wind speed is normal, standard deviation of 3.1. Okay, given the mean of a sample is 12.2, test to see whether it's the actual population is bigger than 9.5. So 9.5 is what I'm writing in here. We've got our sample means, so there we go. Mean should be 0.5, that's what we're testing. You get 3.1 squared over n. N was 25. So we're all set up, ready to go. It's a one-tailed test. We're trying to test whether we're greater than our value, and the significance level is 2.5. So the area there, 0.025. The mean 9.5, and we're trying to find out what our critical region is. So back onto the calculator. Inverse normal. To the right is our tail, so if you're going to the left, you need to do 1 minus. Area 0.025. Sigma for 3.1 over root 25, which is 5. And mu is 9.5. Cool. Execute that, and we get our critical region, or critical value, is 10.52. Cool. So, I'm in the way a bit there. That's my critical region is greater than or equal to 10.52. So they've got a mean in the sample of 12.2. So 12.2 is critical. Therefore, I didn't even state my hypotheses. That's terrible. H0 mu is 9.5. H1 mu is greater than 9.5. So 12.2 is critical. Therefore, reject H0, accept H1. And we can say there is evidence to suggest the mean is greater than 9.5. So mean greater than 9.5. Cool. All right, we've probably got time for one more. You guys aren't really asking many questions today, so please, please say if you need any help. Okay, we're going to try the climbing rope one, which is quite a big question, like I said earlier. So I might try and shrink it so we can fit all of this in. Cool. Right, there we go. Hopefully that's readable. Let me know if it's not, and I can make it bigger. But all I've got to write on is that tiny little bit of screen here. So yeah, um, give it a go. And what's it worth? 8 minutes. Give me 5. I'll give you guys 5 minutes to get started on this one. But we will need to go through it before then. Actually, let me think. Friday. Okay, what we'll do then, I will not go through this today. We'll go through this at the beginning of Friday's lesson, so I'll make it a bit bigger. I want you guys to try this now for the next 15 minutes, and please comment when you get stuck. I want to give you some help via the chat. So, part A, we've got a try and find a probability of Alex. So we've got climbing rope manufactured 1 meter lengths of breaking strength that are normally distributed, which you guys can't see anymore. Good. Still not quite. All right. There you go. So yeah, climbing rope is produced by a manufacturer, is known to be such that 1 meter lengths have breaking strengths that are normally distributed with mean 170.2 and standard deviation 10.5. So we know the mean and sigma. So part A, find the probability a length of rope will have a breaking strength of 175 to the nearest kilograms. So we need to do slightly more than 175, slightly less than, and test that value with our normal distribution. Find that probability. Part B, we've now got a random sample. So this is starting to we're looking at the means. We're not doing a hypothesis test yet, but we are looking at the sample means. And then part C is our hypothesis test. So then we're changing the ropes. We want to test if the means have increased, whether the mean breaking strength is greater than what we had originally. So if you guys copy that down, start it today, but we won't go through it till Friday. Anyone need any help? Anyone need any help at all? You guys quite quiet today. If you want some hints, let me know. I'll tell you how to do part A, maybe. Yeah, which bit, Lucas? How do you do normal PD for part A? Okay. So you got one me. So if I'll write it down at the bottom here. So braking strength. 170 and 10.5 squared. We want to try and find the probability it has a strength of 175. So if I draw it, what's to the nearest kilogram? Well, if you think 175, what would round to that? Well, we'd have 174.5 to be to what would stop rounding down to it? 175.5. So I want to find the probability it's within those two those two limits using this distribution here, and type it all into the calculator, and that should find it for you. Is it 0.34? 0.03. I got 0.0342. Yeah, that is correct answer. Good job. Oh, really? What for the actual value? You would probably need to show your workings. You'd need to have this bit in your workings. Yeah, okay, so maybe it does find it to the nearest integer. Yeah, okay, cool. You would probably need to show, because it's 2 marks, you would want to have the bit up there in red. Cool, yeah, that must be it. Thank you. I've learned something new about the calculator today. Ooh. Right, you got 5 more minutes today on this, guys. If you want to have another look at it before Friday, I would advise it. Maybe rewatch this video, um, and then try it when you've had a bit more practice, a bit more time watching how to do these questions. Cool. Right. Just for the last 5 minutes, so I can show you guys something else. If you kind of pause this or screenshot it, you can get back to this one. Um, we are going to start doing homework assignments. You'll be excited to hear. So I'm going to try and show you guys how to do that now quickly. So if I go to Safari, and if you go onto Moodle, cool. If we go My Courses, A2 Maths, if you guys log in, this is gonna be interesting. I should probably hide my password. Doo-doo-doo-doo. Weird. Okay, so if you go on to the standard A2 Moodle and scroll all the way down. Nice, Lucas. So if you scroll all the way down to the bottom on Moodle, underneath all the assignments, all the past papers, you'll find a new section which I've worked very hard to prepare for you guys. So this is where you're going to do your assignments and skills checks. The solutions are in the folder. The way you're going to do it, if you click on assignment plus skills check 24, which I think is the next one for you guys, there's some instructions for you. So it says, please upload the assignment questions you want help with. So if you get stuck on any, you can upload a photo of them. Complete the skills check, writing the answers in the boxes provided, and you need to upload a photo of your skills check and workings so that we can mark it. So I'll show you quickly what it looks like. So standard skills check, as you'll have seen them before. Don't write anything in this box unless it ever asks you to. You can upload your workings with this uploader here. And then you're going to type your answers in part A and part B. And what this will do, it will instantly mark your work. It will send it to your lecturer. Your lecturer can read it through, check your workings, decide if you get full marks or not, update your marks and put some comments on it. So we can do all your marking of all your assignments and skills checks via Moodle. So from Friday, because I think this assignment 24 was due in a week or two ago because I was ill for the end of the week. I would like you guys to submit that for me. So I need, even if you had no trouble with the assignment, just take a couple pictures of it so that so I can see you've done it. And then complete this. I'll get it marked and we'll start getting homework done again. So every Friday still from now on, start working for assignments. They're all there. You're welcome to work at your own rate, but I do expect them all to get done. And to be honest, the last one, if you have a quick look. Oh wait, not this one. Assignment 29 is on hypothesis testing, so you might want to start it early, use it for some practice, because we are a few assignments behind, as you can see, because of all this chaos. So binomial hypothesis test is there. I think there's actually 3 different normal distribution assignments. So if you guys could start working through those, that would be excellent. Okay, did the government tell me anything about how? Not yet. Nope, we still don't know. Still not heard anything. As soon as we do, you guys will know. Cool. Unless you got any questions, guys, I'm going to end the stream there. If you want to rewatch this one, I would maybe rewatch the one later because I'm going to try and sort out what's going on my screen because I can't see most of what's on the iPad. All right, cheers, guys. Any problems, let me know. Thank you. Bye.